Our discussion today will be regarding the data flow and the timing diagram of microprocessor 8085. To understand the communication between the microprocessor and the memory or the I/O, we first need to examine the timing sequence of the events. Every microprocessor works as per the instruction which is loaded into the memory in the form of operational codes. The microprocessor fetches the instruction from the memory, decodes it, and then executes the instruction. Hence, the instruction cycle can be summed up like fetch cycle plus execution cycle. Now, the microprocessor 8085 basically follows the von Neumann architecture. Von Neumann architecture is also known as stored program architecture. A stored program digital computer is one that keeps its program instructions as well as the data on which it is going to perform any type of operation in the read write or the random access memory. Now, the microprocessor is basically connected to the memory which is having a 8-bit word size, and the maximum address bus that it can be connected is 16-bit, that is 64 kilo locations can be addressed from the microprocessor 8085. Now, in most of the cases, is not all the space is covered by the memory. That is, a memory of size 64 kilobyte is not always connected, and it all depends on the manufacturer of the microprocessing kit, and it chooses the range of memory that needs to be connected. Now, the entire memory is broken into two sections. One is called the system area, the other one is called the user area. A system area is basically reserved for system use. Usually a monitor program is stored in that particular section, which we can call its OS, which manages all the resources that have been connected with the microprocessor unit 8085. Now, the user area is the programmable area which has been provided to the user for loading the programs. Before we can understand the communication and bus timing, we need to understand what type of memory module that are connected in the module MPUs. In memory module that are connected to MPU are basically categorized into two groups, primary and the secondary. The primary is can be volatile, it can also be non-volatile. Under non-volatile, we have ROM, PROM, EPROM, EEPROM, and flash. In case of volatile, we have SDRAM and DRAM. Now, we are also having secondary memory devices, are also known as auxiliary storage, secondary storage, and secondary memory or external memory are all non-volatile type of memory. They are actually not directly accessible by the CPU because it is not accessed via input output channels. Now, the secondary memory devices are flash, magnetic tapes, magnetic hard drives, optical disc, and sometimes punch cards. Now, let us see what a primary memory actually looks like. A primary memory will have address bus in our case. If we consider a total of 16 bit, then a total combination of 16 bits will give us more than 64 kilo locations. Now, this represents a block diagram of a RAM or a EEPROM. Now, it will consist address bus, it will consist a data bus, and it will consists certain control bus or the control sequence. Now in this case, since it is a read write memory, we will have a read as well as write signals, as well as we will have a master select which will be used to enable disable this memory chip. Now what is a memory map? Now since this particular memory is having 16 address bus, we will write that in the section of 4s, that is A0 to A3 4 bits, A4 to A7 again 4 bits, A8 to A11 again 4 bits, and A12 to A15 again 4 bits. So if there are 16 address lines, then this particular address line can have a total combination of more than 64 kilo. So the first will be all zeros and the last one will be all 1. So the location, the range is basically written in hex notation. It will be quad 0 to quad f. That this is this f, this one and this one. Now let us try and understand how a particular operational code is fetched from the memory to the microprocessor unit, where it is stored in instruction register and then it is decoded, and then the microprocessor will be able to understand what type of instruction has been given for the operation. Now let us try and understand how the instruction move a comma b will be fetched from the memory. The operational code of move a comma b is 78 hex. Now the operational code will be loaded into the memory, and obviously it will be loaded in the user's location. Let us assume that the operational code is written across the memory location E000. Now again, let me remind you, E000 location is the location which is provided by the system manufacturer for programming. Now let us see how it is fetched and how it will be decoded. Now the meaning of move a comma b is that a content which is inside the B register will be copied to the accumulator of the microprocessor 8085. Let me remind you, move a comma b here, the source is this, that is the B register, and destination is the accumulator. It is always destination comma source, and we have to remember one thing, there is nothing called cut paste, it is only copy paste. That means even if you copy the content of B to A, the content of B will remain the same until and unless it is erased in the next sections of the program. Now the MPU 8085 places the address E000 into the program counter. The program counter is basically divided into two. It is a program counter high and it is the program counter low. So the program counter high and low will be having E0 00. Now once the address is placed on the address bus, the memory takes some time to find the required data. Now referring to the timing diagram, we can see, here we can see the first T state where the upper address bus is having E0 which is directly connected to program high, and the lower order address bus which is directly connected to program counter low, which are having E0 and 00. Now this particular T state is the addressing T state. So during the time T1 or the T state T1, the MPU sends the address and it is carried by PC high and PC low, as we have seen in the timing diagram. During the T state T1, the 8085 is in the addressing mode. During this time, the address latch enable is also high, which enables the latch and it becomes transparent. The output of the latch now has the lower order address, which is nothing but A7 to A0, which is now carrying 00. Now let's see the data flow. This is the memory whose location is having the data 78, or sorry, in this case we will consider this as the operational code. Now the program counter is having the address E000, and corresponding to that we have the operational code 78. Now after it is fetched, control unit provides a read signal which will transfer the content into the internal data bus, and it will be carried to the instruction decoder where it will get decoded. Now we have to remember that the microprocessor has an internal data bus of 8-bit, whose combination is 256, and there are actually 256 operational codes of the microprocessor, but only 246 were revealed and 10 were hidden by Intel. Now this instruction decoder will find the operational code, or actually it will decode the operational code corresponding to move A comma B out of 256 possible combinations, and it will provide and it will enable the internal hardware circuit that is available inside the control unit, which will generate the appropriate control signals so that the content of B gets copied into A. Now if we see the timing diagram here, at first it is in the addressing mode where the microprocessor program counter will be having E000, and the memory will try to find out the data corresponding to E000. Now when the data or the operational code is ready, it will be inside the data bus, and when a read signal is applied, that particular operational code or the operand will get inside the microprocessor. We can also see that this is a particular machine cycle where we have fetch as well as execution. Now we have to remember one thing, it is not always true. Sometimes the fetching of the operational code is possible in this instruction, in this machine cycle itself, and execution is also possible. Now when we are talking about move A comma B, it is assumed that the content inside the B is preloaded. That means before we are executing this particular instruction, B register is already having the content in it. So when the microprocessor is decoding this particular operational code, it takes 3 machine cycle, and in the last T state the execution is performed, that is the content of B is copied to the accumulator. Hope you have enjoyed the video. Thank you very much.